All right, so for the first one, they gave me this polynomial expression, x cubed plus 2x squared minus 4, and then they told me that it's divided by x plus 2. So just like I was doing just now in the example, first you'll say x into x cubed will give me x squared multiplied by x, that's x cubed, but you also have to multiply it by 2. So x squared times 2, that's 2x. Remember, you're always subtracting them. Subtract. X cubed minus x cubed, that's 0, so you don't have to put the 0. And 2x squared minus 2x squared, that's 0. You don't have to put the 0, like I said, right? Let me just put this one. Then you bring down the other term. In this case, the other term is minus 4. Minus 4. Repeat the process. So it's x into 0x squared, not 0, x. Remember, I said you don't have to put the 0. It's understood. 0x times x, that's 0x squared. 0x times 2, well, anything multiplied by 0 is 0. Let me just put plus 0. Remember, you're always subtracting them. 0x squared minus 0x squared, that's 0. Minus 4 minus 0, that's just going to give me minus 4. So for this example, they asked me to identify the quotient and the dividend. Well, my answer for this is my quotient. You don't have to put 0x, 0x is understood. This is my remainder. My remainder is minus 4. Everybody good? Yes, no?
Yes.
Yes.
Okay. Next one. They asked me to find the quotient and the remainder again. And it's this 3x cubed plus 5x minus 3. And then they told me this is divided by x minus 2. However, if you started dividing this, right? So let me say, okay, I just wrote this, time to divide. I say x into 3x cubed, that's 3x squared. 3x squared times x is 3x cubed. And then I say 3x squared times minus 2. That's minus 3x squared, right? And then I do what I know I'm supposed to do, I subtract the both of them. But then you're ready to subtract, and you're like, okay, hold on, that's a cube. That's a 3. I say, okay, 3x cubed minus 3x cubed, that's 0. But 5x minus 3x squared, 5x and minus 3x squared, they are not like terms. What does that mean? I cannot subtract them. So you could continue like this. Or, because you know a polynomial, what we went through, a polynomial is in this form, ax to the power of n plus bx to the power of n minus 1 plus cx to the power of n minus 2. If you look at this, right? 3x to the power of 3. According to my rule, the next term is supposed to have squared as the power, right? But I don't see that. I see 3x cubed and then I jump straight to 5x. But what does that mean for me? That just means that the term that has x squared is just 0. It's just 0, right? What do I mean by that? Just in case you're kind of confused and you're not following right now. That means I can rewrite this polynomial expression 3x cubed plus 5x minus 3 as 3x cubed. We said that the term, well, the coefficient of x squared in this case is 0. And then I have the 5x, and then I have the minus 3, right? So it'll just be easier for you to rewrite this like this, so that you don't come across this problem where you're like 5x minus 3x squared, they are not like terms, so I can't subtract them. By rewriting it as this, you get rid of this problem. Let me show you how that gets rid of that problem. Let me just erase this. And I'm rewriting my polynomial like this, right? I'm actually putting in 0x squared. Now let me put it in blue. 3x cubed plus 0x squared plus 5x, and then I have the minus 3. Like we were doing before, x into 3x cubed, that's 3x squared times x, 3x squared. So I put the 3x squared here. 3x squared times minus 2, that's minus 6x squared. Now I could get rid of this problem, right? I have x squared and I have x squared. So because they are like terms, I could subtract them. So 0x squared minus 6x squared, so a minus and a minus is a plus. That's going to give me 6x squared. Then I could bring down my minus 5, plus 5x. Continue the process. Was that a 2? Wait, it was plus 2? No, it's minus 2. Okay, no. That means I probably wrote something wrong just now. Anyways, this is the right thing, right? X into 6x squared, that's going to give me 6x plus 6x. 6x times x, 6x squared. Let me just erase this. Gosh. Six x squared. 6x squared. 6x times minus 2, that's going to give me minus 12x. Remember, we subtracting them. 0, 17. Bring down the next one. So just continue in green, right? X into 17x, that's plus 17. 17 times x, that's 17x. 17 times minus 2, that's minus 34. Remember, we subtracting them. We always subtracting them. 17x minus 17x, that's going to give me 0. And minus 3 minus 34. So I can also say minus 3 plus 34 is 51. They asked me for the quotient and for the remainder. This here is my quotient. This is my remainder. Everybody good? Yes, no? Okay. Oh, if there's somebody answering, I'll just
Yes, I don't really understand this.
understand what? Don't really understand what?
Yes, I understand like 50%, but I don't fully understand this.
You understand the process, but you don't understand this?
I don't know how to explain this. I don't really understand this.
What about this one you don't understand?
This I don't know how to explain this. But I don't fully understand, but I understand some. Miss, I don't really understand.
Okay, but don't really understand which part. of it. You don't understand how to long divide?
Miss this miss the Miss, I don't want to explain this.
But if you don't, okay, well, if you don't know which part you don't understand, then okay. Let's do this again. You understand why I put the 0x squared? Yes or no?
No.
Okay. Let me put the original polynomial that they gave. The original one is 3x squared, cubed, plus 5x minus 3. And then we said divide this by x minus 2. X into 3x cubed, that's 3x squared, 3x squared plus squared multiplied by x, that'll give me 3x squared, cubed. And then 3x squared multiplied by minus 2, that's minus 6x squared. And we subtracted them. You understand that so far?
Yes.
Okay. Why I put the 0, but I said you don't have to, because, okay, you do all this and you come down to this part here. Time for you to subtract. So you say 3x cubed minus 3x cubed, okay, that's 0. 5x minus 6x squared. 5x, 6x squared. They are not like terms. Therefore, I cannot subtract them. And if you're doing this way, right, without putting the 0x squared, you could just put back the minus 6x squared and then put the plus 5x. You good with that? So you didn't have to use the 0.
Yes, please.
I just thought it would have been easier, so you could do the same method and just bring down whatever and bring down whatever. But if you don't feel comfortable using the 0x squared, you could just do it like this. You don't have to use the 0. So you good with it now?
Yes, please.
Okay. Everybody good with this?
Yes, Miss.
Okay. Well, this is not minus, this will be plus. Plus the minus, only minus plus, right? That's plus 6x. Okay. You don't have to use the 0x squared. Some people just find it easier, so you could just follow the same method and bring down the numbers in order. Or if you're comfortable with this way, you can do it this way, right? Okay. Oh, there's another one. This one, this is a polynomial to the 4th degree, and that's the highest they require you to know, right? Up to the 4th degree. And what do I mean by a degree? Well, let me show you. So this long polynomial that they gave you, is 5x to the power of 4 plus 3 x cubed minus 2 x squared plus 4x plus 5. This long polynomial expression. And then they want you to divide this by x minus 3. So what do I mean by polynomial of the fourth degree? You see this number, this power here? The degree of a polynomial is the highest power, right? So I see out of this entire thing, this entire expression, 4 is my highest power. That's why I would say this polynomial is to the fourth degree, because my highest power is 4, right? So that's what I mean by fourth degree. And that's what you will see on the syllabus objectives. You're required to know how to divide polynomials of the fourth degree. That's what they mean by fourth degree. 4 is the highest power. Okay, same concept. It's just this one would take a little longer than the others. Because I see 1, 2, 3, 4, 5 tunes here. And the other ones had like 3 tunes. 3, 4 tunes. No, 3 tunes. Okay. X into 5, x to the power of 4. 5x cubed multiplied by x, that's going to give me 5x to the power of 4, 5x cubed multiplied by minus 3, that's minus 15x cubed. Remember, we are subtracting. So 5x to the power of 4 minus 5x to the power of 4, that's going to give me 0. I don't need to write the 0, it's understood. Then the next one, 3x cubed minus 15x cubed. So minus and a minus gives me a plus. That's why this right here is 18x cubed. Continue the process. X into 18x cubed, that's plus 18x squared. 18x squared multiplied by x, that's going to give me 18x cubed. Oh wait, I didn't bring it down. You want to bring it down, right? I just using the same color. But if you want me to switch the colors, just let me know, right? 18x squared multiplied by minus 3, that's going to give me minus 54x squared. Remember, we are always subtracting them. 18x cubed minus 18x cubed is 0. Minus 2x squared minus 54x squared. Minus and a minus would give me a plus, right? So this is 52x squared. Bring down the next number, which is 4x. Same process. X into 52x squared, that's plus 52. X. 52x multiplied by x, that's 52x squared. 52x squared. 52 multiplied by negative 3, that's minus 156x. Gosh, that's an x, right? We subtracting them. 52x squared minus 52x squared is 0. 4x minus 156x, that's 160. 160x. Can I erase this, please? So I can have more space to finish it.
Yes.
Yes, I understand. I kind of understand more better.
Okay, cool. So erasing this whole thing, right? Erase. Okay, I can scan. Anyway, let me continue in yellow. So the number we have now is 160x. X into 160x, that's give me 160. 160 times x. Oh wait, I brought down the 5, right? So that's 160 160 multiplied by minus 3 is going to give me minus 480. Remember, we always subtracting them. 160x minus 160x, that'll give me 0. 5 minus 480. So minus and a minus is a plus. And that's why my remainder in this case is 485. They asked me for the remainder and the quotient. Well, this is my remainder and this is my quotient. Everybody good with that? Yes? No?
Yes, Reese.
You understand everything?
Yeah, but I'm going to practice.
Okay, cool. Well, we have time. Remainder and factor theorem now. That was just the basics, right? Basic operation of polynomials. Addition, subtraction, multiplication, division. Now we on to remainder theorem. What is the rule for remainder theorem? Well, if I'm given a function f of x, and this is divided by x minus a, then f of a is the remainder. These are the past paper questions we're going to do, right? But just now we will do that. How exactly do you use the remainder theorem? Well, the first thing you want to do is make the divisor equal to 0 and solve for your value of x. So looking at this example, right? They asked me, what is the remainder when this function, g of x, is equal to 2x cubed plus 4x squared plus 3x minus 1, and it's divided by 2x plus 1. First step, it says make the divisor. Remember, when you're dividing, this is called the dividend. So whatever is here is the dividend, and then this outside here, the number you're dividing by is the divisor, right? So that's what I mean by divisor, right? So yeah. So the first thing you're doing, you're taking this divisor, you're putting it equal to 0 to solve for your value of x. That's what I have here. 2x plus 1 is equal to 0. If I want to solve for x, x is going to be minus a half. What's the next step? Oh gosh, I forgot the t. Anyways, next step, sub, which means substitute, the value of x into the function. What do I mean by that? Well, I got that x, the value of x is minus a half. I said to substitute that value into the function. Well, since we know that g of x is 2x cubed plus 4x squared plus 3x minus 1, if I replace this x, if I replace x with minus a half, what I would get is g of minus a half is going to give me 2 minus a half cubed plus 4 minus a half squared plus 3 minus a half minus 1. What did I do? I just took this value of x, and wherever I saw x in my polynomial expression, I replaced it with minus a half. Everybody good with that so far?
You can go back over that step, please.
Miss.
Step two.
Yes, miss. Do it over, miss.
Okay.
Repeat it one more time.
The first thing you want to do, put the divisor equal to 0. This is my divisor. Why is that the divisor? That's what I'm dividing by. So hold on, let me just show you what that would look like real quick. So the polynomial expression says 2x cubed plus whatever, right? And they told me this is divided by 2x plus 1. This right here, this is my divisor. And the first step, it says put this equal to 0 and solve for the value of x. That's what I did. Here, 2x plus 1 is equal to 0. So x is going to give me minus a half. Step 2. Substitute the value of x you just got, which is the minus a half, into the function. The function is g of x. They told us that g of x in this case is 2x cubed plus 4x squared plus 3x minus 1. So what do I mean when I say substitute that value into the function? Well, wherever I see x in the function, I'm going to replace it with minus a half. Yes, let's do that on the board. It told me the function g of x is equal to 2x cubed plus 4x squared plus 3x minus 1. I said from my first step, I found out that the value of x is equal to minus a half. The second step says take this x value and sub it into my function. What do I mean by sub it into the function? Well, that just means wherever I see x, I'm going to replace it with minus a half. So the value of x, I said the value of x is minus a half. Wherever I see x in this function, this polynomial expression, instead of putting x, I'm going to put minus a half. That's why I have 2 by minus a half cubed plus 4. I see an x here, but instead of putting x, I'm going to put minus a half. Minus a half squared plus 3. I see x here, instead of putting x, I'm going to put minus a half. Minus a half minus 1. You good now?
Yes, please.
If it's not good, let me know. That's what that second step is. Substitute the value of x that you got in step 1 into your function. Wherever you see x in the function, you're going to replace it with the value you got. We got minus a half, so instead of putting mark x, I'm going to replace it with minus a half. What answer do I get? Well, when I do all of that and I simplify it, I get my answer to be minus 7/4. But what exactly is that value? What's the purpose of doing that? Well, according to my rule, if a function f of x is divided by x minus a, so in this case, x minus a is your divisor, right? Divided by x minus a, so that's the divisor. And in our example, divisor is 2x plus 1. According to the rule, the remainder is f of a. So maybe this example wasn't the best to show you that. Let me show you this other one. Say I was given, let me come up to this. I think I would do another example of that one afterwards. So the rule says if you're given f of x and this is divided by, so your divisor is x minus a, then the remainder is f of a. F of a is going to give you a remainder, right? Whatever f of a is, that's the remainder, the value that you get. So if you're given a divisor, so say it was x minus 1, that was your divisor. So in the example I just showed you, the divisor was 2x plus 1. But say our example was x, our divisor was x minus 1. To find the remainder, this, remember the first thing you do, set this equal to 0 to find the value of a. So x is equal to 1, right? And the next step, it said substitute this value into the function. So what I was saying, what this rule says, f of 1 whatever value you get after, replacing the x's with 1, that answer is going to be your remainder. So back to this one. After substituting the minus a half into my function, the answer I got was minus 7/4. What does that mean? That means that the remainder is minus 7/4. You might be wondering, what's the purpose of this remainder theorem? Well, you see how we were doing long division just now, where you had your polynomial expression. So let me just use 2x cubed again, plus whatever, blah, right? And it's divided by 2x plus 1. Instead of doing all of that whole long division thing, 2x into 2x cubed, whatever, get that whole long thing, that's going to take up time. That's the purpose of this remainder theorem. According to the theorem, if I just put this divisor equal to 0 and get a value for x, I could substitute that value of x into my polynomial expression to get the remainder. That's a shorter method instead of doing that whole long division thing, then to get the remainder minus 7/4. Right? Everybody good so far? Hold on. Let me end this, rejoin, and then tell me if you good.